All right, let's get started here with multiplying and dividing rational expressions. So we'll get started by doing the excluded values first. I kind of always like to take care of those first because sometimes they go away after we do some canceling out, but they should carry forward. So for excluded values, much like our first section, we're going to take the denominator and say that the denominator cannot equal 0. Now, in this case, we may have multiple denominators, so technically we're supposed to say that they both cannot equal 0. And so technically I'm supposed to solve these, so then m to the third cannot equal 0, and then we cube root that, and so m cannot equal 0. And then over here, divide by 2, so then m cannot equal 0 again. So we came to the same conclusion twice. I would only box that up once there. Just m cannot equal 0. Now, the shortcut that I'm going to be doing from here on out, anytime we have a variable in the denominator and there's no adding or subtracting, there's just multiplication, it's actually always going to come out to 0. You kind of saw we had a third power there multiplied by 3. It doesn't really matter. It's always going to come out to 0 either way. So I showed my work on that one, but going forward, I'm going to kind of take away that step. And just say that the variable cannot equal 0 if it's in the denominator with no addition. Okay, so now for simplifying. For this one, we're going to cancel stuff out from top to bottom. And the trick on these ones is it doesn't have to be part of the same fraction. So I can do something up here with something down here, something up here with something over there, or something that way or that way. So as long as it's top to bottom, if these are multiplying, I can cancel stuff out. So I notice here with these m's, they can kind of partially cancel out. I'm left with one m on bottom. I always think of that like a kind of battle where the bottom wins by 1. So I'm going to leave with m to the first on bottom. I can reduce these two by dividing by 2. So it's going to be a 2 on top and a 1 on bottom. And then I have a 2 here, a 3 here, and an m there. I don't see anything I can do with. And so I can kind of just double check here. Is there anything else I can cancel out? I don't see anything. We cannot cancel out these two because it's top to top. We have to cancel out top to bottom. So when I'm all done then, I just multiply top times top up top, and then bottom times bottom on bottom. So that's going to be 3m squared on bottom. The m to the first times m to the first gives me m to the second. All right, so that's it. Okay, it's the same idea here for number 2. So I'm going to go ahead and use that shortcut I talked about on number 1, so you can go back and watch that. But any time that we have a variable in the denominator with no adding or subtracting, that variable is not allowed to equal 0. Okay, so now we'll do our simplification here. So these x's can just cancel out. These x's can partially reduce. When I draw my fraction here, I would say that's x to the first left on top. It's kind of won that battle by 1. With a 2 and a 10, we can reduce that by 2, divide by 2, so that's going to be a 1 on top and a 5 on bottom. With these ones over here, I can reduce those by 2 as well, so it's going to be a 2 on top and a 5 on bottom. I double check here. I don't see anything else I can cancel down. So I'm just going to do top times top up top, which would be 2x, and then bottom times bottom on bottom, which would be 25. All right, next up, number 3. So for this one, I once again see I do have a variable in the denominator here, kind of right there. And there's no adding or subtracting. So like I said, that's always going to be x cannot equal, or whatever the variable is cannot equol 0. Okay, so now we're going to simplify. So I see that these two can just actually cancel out because they're the same thing top to bottom. Hold on, let me do that so I'm not including that x there, okay. And then these two can partially cancel. If I divide them by 2, I'm going to have a 2 on bottom and a 1 on top. And then this x to the third can reduce with this x to the third here. Remember that even though they're not part of the same fraction, they are multiplying fractions, so we can reduce anything top to bottom. And so I'd say that that's going to be an x squared left on top here, because this is x to the first on bottom. So I always think of it as like it's going to kill one of those x troops on top. So there's 2 left over. So I don't see anything else I can cancel out, so I'm going to do top times top on top, bottom times bottom on bottom. All right, next up here, number 4. So for this one, I once again see we have that a variable on the denominator here, so that means that variable cannot equal 0. There's no adding or subtracting there. All right, now we'll simplify. So I can reduce this 8 with that 8. They can actually just cancel out. And then I can cancel these ends out right there. I don't see anything else I can cancel out. Let me just rewrite it here to be sure. So that's what's left over now. So top times top up top, bottom times bottom on bottom. There we go. All right, next up, number 5 here. Now this one, let's see. The denominator here does have a variable, but it's not. But there is adding and subtracting. It's not just multiplication. So I have to factor this one. So I'm going to go ahead and do that. So we're going to think of two numbers that multiply to negative 48 and add to 2. So I think that would be positive 8 and negative 6. So I'm going to split up that middle term. So I got 8x minus 6x minus 48, and then x squared up here. Then I'll do my grouping. So the first group I can take out an x, which leaves me with x plus 8. The second group I can take out a negative 6, which would leave me with x plus 8. Remember, taking out the negatives, which is the signs there. And so I have x plus 8 times x minus 6 cannot equal 0, which would mean that x plus 8 cannot equal 0, and also x minus 6 cannot equal 0. So if I subtract the 8, it would be x cannot equal negative 8. And if I add the 6, it would be x cannot equal 6. So we get 2 excluded values there, okay? All right, now for the simplification, I'm actually going to, since I've factored this, I'm going to kind of use that for my simplification here. So I'm going to rewrite the bottom of the 5 as x plus 8 and x minus 6 from my factored form. And I can actually do the same to the top left because you can see that's the same expression. So I can copy my own work there. And then I can cancel out now in factored form any parentheses that are exactly the same. So I can cancel out x plus 8 with x plus 8 and x minus 6 with x minus 6. So I'm just left with 5 over 7. All right, number 6 here, I do have some stuff in the denominator. It's adding, so I need to set it not equal to 0. And so I have 2 denominators here, so I need to, and they are different, so I need to set them each not equal to 0. So the first one, I'm going to subtract the 1 over, so I get x cannot equal negative 1. And then the second one, I subtract the 8 over, so x cannot equal negative 8. All right, now for simplification, I'm going to need to factor this numerator up here. So I'm going to think of two numbers that multiply to negative 10 and add to negative 9. So I think that would be negative 10 and positive 1. So I'm going to rewrite this as x squared minus 10x plus 1x minus 10. So I'm going to group that up. The first group, I can take out an x, leave me with x minus 10. The second group, it looks like I cannot take anything out, but that means I have to take out either a 1 or a positive 1. In this case, it's a positive 1, which will give me x minus 10 as well. So I have x plus 1 times x minus 10 up top. I'm just going to go ahead and rewrite everything else here because that was the only thing I needed to factor. And then we see, and I like to put those other ones in parentheses as well. It's the same, kind of means the same thing. So then what can I cancel out here? Well, I can cancel out the x plus 1s. I don't see anything else, so we'll just do top times top up top and bottom times bottom on bottom, and we're done. All right, next one here, we do have denominators, so we know the denominators cannot equal 0. And so if I subtract the 4 over, b cannot equal negative 4. If I add the 7 over, b cannot equal 7. So those are my excluded values. Now to simplify it, the only thing I can factor is this top right, and the only factoring I can do is actually GCF. I can pull a 2b out front, and then I have b plus 4 left on the inside. Everything else kind of stays the same here. And what can I cancel out? Well, the b plus 4 with this b plus 4. So nothing else cancels, so I get 2b times b minus 1 on top, and then b minus 7 on bottom. We're not allowed to cancel out these b's because this b has something subtracting to it. So you have to kind of think of that as a parentheses on bottom, if you will. And so it'd have to be another b minus 7 to cancel that out. One more thing, you could distribute the 2b in here. That's fine. I don't think it's necessary, so I wouldn't do it. I would just save myself a step and write my answer like that.